Do you guys want to know what my least favorite part of chemistry is? It's these laws like Boyle's law, Charles's law, all these little tiny gas laws that really just come out with the ideal gas equation, but instead they make you learn it separately. Like Boyle's law, which says that the product of pressure and volume is always the same as long as you have the same number of moles and in the chamber and the same temperature. What we really mean is if we compress the volume down, the pressure goes up, and if we expand the volume, the pressure goes down. And it works exactly like this relationship, P1V1 equals P2V2. Here's an example. I'm going to start with a 2-liter chamber, and it has 102 kilopascals of pressure inside, all right? But then I'm going to compress that chamber down to 0.8 liters. I want to know what the new pressure is inside. Now I have the same number of moles inside, and I'm going to assume the temperature is the same. So compressing that space down should increase the pressure inside. The molecules have nowhere to go, so they're under a higher pressure, trying to get out, forcing themselves against the walls. So how do we figure out what that new pressure is? Well, the answer is Boyle's law, P1V1 equals P2V2. My initial pressure was 102 kilopascals. My initial volume was 2 liters. I'm going to not bother showing my units. As long as you use the same units on both sides, they cancel out anyways. My new pressure is what I don't know, and my new volume is 0.8. So, how do I solve for P2? Well, the answer is I take my 102 times 2 and I divide it by 0.8. We undo this multiplication by dividing on the other side. And this is where I call in my best friend, Nick Cannon. 102 times 2 divided by 0.8. 255. So all of a sudden, my pressure is up to 255 kilopascals. Interesting thing I'd like to note is the volume is less than half of the original volume, so the pressure is more than double the original pressure. That's how this kind of stuff works, all right? Let's do one more together. That's what best friends are for. We've got a 50 milliliter balloon with this current pressure inside, and it's allowed to expand. So my volume is changing so that it has a pressure of 101.3 kilopascals. What's the final volume, they're asking? Okay, so I'm given pressures and volumes. P1V1 equals P2V2. That's Boyle's law. Boyle's law. Anyways, my initial pressure was 40 kilopascals. My initial volume was 50 milliliters. And again, as long as you use the same units on both sides, it doesn't matter what the units are. P2, they gave us as 101.3. And my new volume is what I don't know. So, how do I solve for V2? Well, I take my 40 kilopascals times 50 milliliters and divide it by 101.3. 50 times 40 divided by 101.3. 19.7. And my units for volume were milliliters because that's the number that I plugged in here, right? Cool. Note again that my pressure more than doubled, so my volume is less than half the original volume. One goes up, the other goes down. Maybe it's easier if I do it that way. In any case, Boyle's law is super easy. The trickiest bit is memorizing that this one, PV, is Boyle's law, whereas Charles's law is 2 other variables. Don't get it confused or twisted. Instead, get an A, and then give me a shout out as you get the test back from your teacher. Best of luck.